All right, so we're going to start into chapter 2. All right, folks, let's stop talking, please. Let's get started.
Okay, folks, let's stop talking, please. Let's get started. Thank you.
Chapter 2. Chapter 2 is really kind of right in the heart of algebra. What we're going to be doing is solving equations, finding zeros, factoring, all of that kind of very straight up algebra stuff. Yes, it should be easy. Should be mostly review. So let's start. We'll write this a lot, but a polynomial. Chapter 2 is about polynomial functions. We're talking specifically about quadratic today. Polynomial functions look like this. F of x equals a sub n, x to the n, a sub n minus 1, x to the n minus 1, plus dot dot dot, plus a1x plus a0. Where the a's are real numbers. Those are our coefficients. And n is greater than or equal to 0. So our exponents, our powers of x, are either 0, which makes not a very interesting function, or they're positive. So we have something like 5x to the 5th plus 4x to the 4th minus 3x to the 3rd, etc., etc. That's what we're going to be talking about. If n equals 0, so if the highest power on x is 0, what kind of function do we have? We would just have, this would just be, the highest power of x would be 0. What's x to the 0? 1. So we just have whatever that a is, whatever that coefficient is. What kind of function is that? What, f of x equals 5. F of x equals negative 7. Yeah, it's a horizontal line. It's a constant function. Not a very interesting function. Not much happens with constant functions. If n equals 1, so the highest exponent on x is 1, what kind of function do we have? That'd be linear. It'd be something like 5x minus 2. F of x is linear. In algebra, you have done a lot of work with linear functions. We did a lot of work with linear functions, finding intersections of linear functions last chapter. For today, we have n equals 2. So we're going to say f of x equals ax squared plus bx plus c. And we talked a little bit about this kind of function last chapter also. This is a quadratic function. And we call this the general form. So when we have something that looks like ax squared plus bx plus c, that's the general form of a quadratic function. If we graph a quadratic function, what does a graph look like? It's a parabola. The graph is a parabola. So I want to sketch a graph, and we'll talk about some parts, and then we'll go on from there. All right, so we're good with the idea, the general idea of a quadratic function. All right, so y equals x squared. So that's a nice parabola. I'll make it in blue. So looks something like that. What do we call on the graph?
Wrong room? Hi. Bye. Oh, was that? Hey, that was so unnecessary.
He was just trying to be polite. He realized he didn't come in without saying hello, and he left without saying goodbye. So he did both at once. Not even me. All right. What do we call on the graph, not on our coordinate system? Not on the coordinate system, but on the graph. What do we call that point? Not on the coordinate system, but on the graph. The vertex. That point is the vertex. On this particular graph, it is at the origin, and we call this line that goes through the vertex the axis or the axis of symmetry. And our parabola is symmetrical about the axis. All right, so what we're interested in today, let's stop talking, folks. What we're interested in today is if we have a parabola in general form, not a parabola, a quadratic function in general form, how do we figure out where its vertex is? So we're going to talk about a different form of a parabola. The standard, our book calls it standard form. I will call it, and you'll more usually hear it called vertex form. But our book always calls it standard form. Standard form or vertex form of a parabola is f of x equals a times x minus h squared plus k. The vertex is at the point hk. So we call it vertex form because we can pick out the vertex easily. The axis is the line x equals h. If a is positive, so the number in front of the x squared is positive, our parabola open, which direction our parabola open? Up. And if a is negative, our parabola opens down. In Chapter 9, we'll describe parabolas in a slightly different way, and we'll talk about sideways parabolas as well. But for now, we're just talking about functions, so they have to be vertical parabolas. So what we want to do is, if we have a quadratic function in general form, how do we put it in vertex form? And I always like when we get to this point in the semester, because we get to recall one of our favorite operations from Algebra 2. We want to find the vertex, we want to find the axis, and sketch a graph. Anybody remember how we changed this general form to vertex form? Something that we really liked doing in Algebra 2. Factoring, we'll end up factoring, yeah. We complete the square. So in order to put this in vertex form, we get to complete the square. Notice I didn't say we have to. We get to. We're excited about it. So I'm going to write this when we're completing the square. We're completing the square on this part with the x squared and the x. That's the part we're interested in. So I put it can be helpful to put parentheses around there to remind you. To complete the square, we take the number that's in front of the x, divide it by 2. So negative 4 divided by 2 is negative 2. And we square it. So we get 4. So we're going to add 4. But when we complete the square, we want to really not do anything to the function. So since we added 4 there, we need to subtract 4 out there. So what we've done is add 0. But we've added it in a way that's helpful to us. Because what we've done is turn this quantity in the parentheses into a perfect square. If you don't see it right off, you can think about factoring this. This is x minus 2, x minus 2. So we get x minus 2 squared minus 6. So our vertex is negative, not negative 2, 2, negative 6. This is x minus h and k. Our axis is the line x equals 2. So if I'm going to sketch a graph, there's 2, negative 6-ish. Yes?
If it had been x plus 2 squared minus 6 with the vertex and the negative 2.
Yes. So remember in vertex form it's x minus h and k. All right, so there's my vertex. To sketch a graph. In general, we're not just going to draw a parabola here. We want to know how wide it is. So what we're going to do here is find the x-intercepts. How do we find the x-intercepts? What is 0? Y equals 0. Yeah, you could find a y-intercept also. You were thinking y-intercept, okay? You were just intercept. You just knew intercept meant something meant 0. Something was 0. Okay. Well, you knew that an intercept meant something equals 0. Yeah. Right. All right, so we're going to set y equal to 0. So a function, f of x, y equals 0. So we're going to say 0 equals x minus 2 squared minus 6. And we're going to solve for x. So x minus 2 squared equals 6. And we're going to say x minus 2, take the square root of both sides. And we take the square root when we're solving an equation. Some of us remember that we have to have a plus or minus. That showed up recently. Where we had to take a square root of something to solve something. And we get x equals 2 plus or minus the square root of 6. So we'll sketch a rough graph. Square root of 6, about how big is square root of 6?
2.7.
It's bigger than 2, right? Because 2 squared is 4. Smaller than 3, because 3 squared is 9. So somewhere between 2 and 3. Yeah, 2. Yeah, that's a pretty good. So 2 plus 2.7, so about 4. And 2 minus 2.7, a little less than 0. So there would be a decent sketch of that parabola. Yeah.
Can you go through one problem and really show us on the solid square how to complete the square?
That's what we just did here.
Like,
Yeah,
just
well,
please
but,
say,
like,
yeah.
I was following that.
Like, write out this. Look, Campbell.
Oh, that's
So
quick.
let's not write it. Get this.
Um,
Divide by 2 and then square it.
Square it, right.
So can you write it like this?
Negative 4 divided by 2 is negative 2. 2 squared is 4.
See, that's the kind of like filler thing you got right there.
Yeah, the filler.
Yeah.
You gotta write it down.
Oh, you should write it down. If I say it, you should write it.
But should I be writing
Just
it
write
down
everything
too?
before you say
Yeah, if I do it or say it, you should write it.
But you didn't do it.
I said do it or say it. There was an or in there. All right. I want to do another example where I need to point out another little thing that we have to be careful with when we complete the square. All right, we want to find the vertex. Let's stop talking, please. Let's finish this up. Yes. Stop laughing as well. All right. We want to find the vertex. All right. So we're going to complete the square on this portion. But what's going on here is we have that leading coefficient of negative 2. So what I'm going to do is factor that negative 2 out of this set of parentheses. Negative 2 times x squared plus 2x plus 1. And now I'm going to complete the square here on this portion. So this is my leading coefficient. This is my a that I wrote in vertex form. So negative 2 x squared. I'm going to divide 2 by 2. We get 1, square 1. We get 1. So we're going to add 1.
Wait,
But
hold up. Why are you dividing by 2?
that's how we complete the square. You divide this by 2, then you square it, and you add whatever you get.
One a lot of times.
Yeah, you said a lot of ones.
But we have to be careful here because this negative 2 is being distributed
To the what? To the what?
to everything.
What in specific?
So I'm not adding 1 here. I'm subtracting 2. Because when I distribute this, it's a negative 2. So I have to add 2 out there so that I end up adding 0.
Okay.
So when you factor out that leading coefficient, remember it's being distributed into the parentheses. And I'm going to write this as a perfect square. Folks, this is a perfect square. X plus 1 squared plus 3. And now we have our parabola, our quadratic function, in vertex form. The vertex is at negative 1, 3. This is x minus negative 1. So if we were going to sketch this, which way would this open? Down because of the negative 2. What does that 2 do to the graph? Stretches it vertically. So that 2 would give us a vertical stretch.
Oh, what?
All right, questions there? Yes?
Okay, in the parentheses you wrote x like times like negative 1 times like negative times negative 1. So I could write this negative
because in our vertex form is x minus h. So this is x minus -1. Okay? All right, I want to look at another example similar to the problems we did in the last chapter, kind of related. I don't want to graph this one.
Can you do anyways?
We want to find the vertex form of the parabola with vertex 1, -2 that goes through 3, 6. So in the last chapter, we had 3 points that we wanted our parabola to go through, and we were able to set up a system of equations to solve this. Here we just have 2 points, but one of them is the vertex. When you have the vertex of a parabola, basically you have everything. So this problem is almost solved. We know that y equals ax minus h squared plus k. What does this give us? That gives us our h and our k. What does this give us?
XY.
That gives us an x and a y. So let's plug those in. We've done problems like this before. 6 equals a times x 3 minus 1 squared plus -2 minus 2. And now all we need to do is solve for a. So 6 equals a times 3 minus 1 is 2. Squared is 4. 4a minus 2. 4a equals 8. And a equals 2. So we have f of x equals 2 times x minus 1 squared minus 2.
Carry that.
No. No.
Sammy, that was really mean.
I'm sorry. I'm sorry.
All right, questions on that example? No. All right. Minimums and maximums. Where do we find the minimum or the maximum of a parabola? At the vertex. Mins and maxes. At the vertex. The minimum or maximum value. So we know that we find the minimum or maximum at the vertex. The maximum or minimum value of the function is the y value. So if we want to know what is the largest the function can get, it's asking how big can y get. If we want to know how the smallest that the function can get, it wants to know how small can y get. So if you're asking for the minimum or maximum value, they're asking for the y value. So we wouldn't just say the minimum is at x equals 6. We want to know the value of the function there. How big is the function, or how small is the function? If f of x equals ax squared plus bx plus c, the vertex, a shortcut for finding the vertex, is at, you might remember this from Algebra 2, negative b over 2a, f of negative b over 2a. This is the x value, and this is the y value. So this number would be the min or max value. So what this means is to find the x-coordinate of the vertex, I can do negative b over 2a. To find the y-coordinate, I take whatever number I get once I do this, negative b over 2a, and plug it in for x. Figure out what y is. A lot of students like to only find the vertex this way. That's fine for quadratic functions, but eventually you will have to be able to complete the square. Because in chapter 9, when we talk about ellipses and hyperbolas and da-da-da-da-da, we're going to have an x and a y. So for our problems, we'll complete the square twice. And you'll have to complete the square. If you go on to Calc 3, not if, when you go on to Calc 3, you'll be in three-dimensional figures. You have an x, a y, and a z. So you do complete the square 3 times. This comes from completing the square on this. That's how you get this quantity. And does this negative b over 2a look familiar at all? What is it, Megan? The quadratic formula. Quadratic formula, x equals negative b, b squared minus 4ac, all over 2a. There's negative b over 2a. It's not a coincidence, because the quadratic formula comes from completing the square here and then solving for x. So these are all related. They're not separate things, they're all just one thing. So do you know what parents feed their baby parabolas? Quadratic formula.
Are you saving that one? Because you do?
Yeah. All right, questions? Okay, so remember that thing where we didn't have homework on Friday for a couple of weeks? Several weeks? Yeah, well, you should. Yeah, that's gone now.
That's like at least like 4 questions.
Oh.
Okay.